All right, everyone, get ready because today we're diving into something truly mind-bending. We're talking about the holographic principle. Ever heard of it?
Hmm.
It's this wild idea that everything we see, everything we experience, our entire universe might actually be a hologram,
Yeah.
a massive cosmic movie projected onto the sky.
Wow.
And we're all just living in the projection. And the crazy thing is there's actually some serious science behind it. I've been really digging into this lately, right?
Yeah.
Been going through physicist Dr. Maria Ioana Christodoulou's presentation,
Okay.
even a whole PhD thesis on probing this holographic universe. So we're going to try to unpack it all today, see how deep this rabbit hole really goes. And luckily, I've got our expert here to guide us through the mind-bending physics. So where do we even begin with an idea like this?
Well, the best place to start might be something surprisingly familiar. A hologram.
Like those 3D images on credit cards.
Exactly. Dr. Christodoulou actually uses that very analogy in her presentation. See, just like a hologram packs all the information of a 3D image onto a 2D surface, the holographic principle suggests that maybe all the information about our universe is actually stored on some distant, lower dimensional boundary.
Okay, I think I'm following so far, but it's already making my head spin a little. I mean, how did anyone even start thinking the universe could work this way?
It's not as random as it sounds. It actually came from trying to understand some of the biggest mysteries in physics, specifically black holes.
Black hole.
Yeah.
Those cosmic vacuum cleaners that gobble up everything. What do they have to do with holograms?
Well, that's the thing. Black holes present us with this paradox. They suck in all this information, but where does it all go? It seems like it just vanishes.
Yeah.
And that really messes with some fundamental laws of physics.
Right.
So the holographic principle emerged as a possible solution, a way to make sense of all that information crammed into a black hole.
So you're saying instead of being destroyed, the information gets encoded onto the surface of the black hole, like some kind of cosmic hard drive.
Essentially, yes.
Yeah.
And that's where that PhD thesis you mentioned comes in. It digs into the mechanics of how information from a 3D space could be represented on a 2D surface. And a big part of that is exploring the role of something called quantum entanglement.
Quantum entanglement. Now that's a whole other mind bender we could spend hours on. That's the one where two particles are linked, even across vast distances, right?
Exactly. And this thesis explores how that seemingly bizarre connection might actually be fundamental to the fabric of our potentially holographic universe.
Okay, so we've got black holes, quantum entanglement. It's all very cool, very mysterious. But is there any actual evidence that our universe might really be playing hide and seek with dimensions like this?
That's the million-dollar question, isn't it?
Yeah.
And that PhD thesis you mentioned actually brings up a fascinating piece of the puzzle. It talks about something called anti-de Sitter spaces.
Anti-de Sitter spaces.
Yeah, or ADS spaces for short.
Right. I've got anti-de Sitter in my notes here. Sounds kind of intimidating, not gonna lie.
It does have a certain ring to it, but here's the really interesting part. In these ADS spaces, the math behind the holographic principle, it actually seems to work.
Wait, really? So it's not just a cool idea, it actually works out mathematically.
Exactly.
Yeah.
The thesis explains how in these theoretical spaces, you can describe everything happening inside a higher dimensional space, just using information present on its lower dimensional boundary.
Hold on. So you're saying you could take, like, a 3D object and map every single detail onto a 2D surface?
That's the basic idea.
Wow. So in these ADS spaces, the holographic principle isn't just some mind-bending concept, it's a real mathematical possibility.
Precisely.
But there's always a but, isn't there?
Right.
Our universe isn't an ADS space, right? It's constantly expanding, pushing outwards.
You're right. Our universe is a bit more complicated than that.
So where does that leave the holographic principle? Is it a dead end?
Not necessarily. Think of it this way. The success of the holographic principle in ADS spaces, it's like finding a clue. We might not have the whole puzzle figured out yet, but this clue hints at a deeper truth, something that might apply more broadly, even in a universe as complex as ours.
I like that. A vital clue. It reminds us that sometimes exploring these theoretical spaces, even if they're not a perfect match to our reality, it can still unlock new ways of thinking.
Exactly. And it raises a pretty big question for all of us. What if our universe actually is a hologram?
All right, everyone, time to put on your thinking caps. If our universe really is just a projection of information from somewhere else, what does that mean for us? Does reality become less real? I think I need a little help wrapping my head around this one. It's a question that's probably crossed everyone's mind at some point, right?
Right.
If it's all just information projected from somewhere else, what does that even mean for, well, reality.
It really makes you question everything, doesn't it? And the thing is, this holographic principle, it's not just some abstract idea.
Right.
It forces us to look at the very fabric of our existence in a whole new way. If everything, our experiences, our memories, even our sense of self, if it's all just part of this grand cosmic projection,
Yeah.
what does it really mean for us? It's a question philosophers have been grappling with for centuries. But now, physics is offering a whole new perspective.
And it's not just a philosophical question either.
It's definitely not.
This has huge implications for how we understand the universe on a fundamental level. Like we were talking earlier about those two giants of physics, quantum mechanics and general relativity,
Right.
and how they don't always seem to agree.
Exactly. And that's what's so exciting about the holographic principle for a lot of physicists. It hints at a possible bridge between these two seemingly incompatible theories.
Okay, so walk me through that. How could a holographic universe help unify quantum mechanics and general relativity?
Well, one of the biggest challenges in physics is understanding how gravity works at the quantum level.
Okay.
General relativity, which describes gravity on large scales, it kind of falls apart when you try to apply it to the tiny world of particles.
Right.
But if the holographic principle holds up, it could mean that gravity, as we experience it, is actually an emergent property of this deeper encoded information.
Emergent property.
Like, think about the pixels on your screen.
Okay.
They create the illusion of a continuous image. But really, they're just individual points of light.
Right.
So maybe gravity is similar. An emergent property of the universe's underlying information structure, not a fundamental force itself.
So the universe is basically pulling a cosmic magic trick on us, making us think gravity is this fundamental force, when really it's just an illusion created by something much deeper.
It's a pretty wild thought, right?
Yeah.
And if it's true, it could be the key to finally reconciling quantum mechanics and general relativity,
Yeah.
leading to that holy grail of physics,
Yeah.
a unified theory of everything.
A theory of everything. Now, that's something I can get behind. But even if it doesn't quite get us there, it seems like the holographic principle has already opened up a ton of new possibilities for physics.
Absolutely. It just goes to show how much we still don't know about the universe.
Yeah.
And it's a reminder to keep questioning, keep exploring, be prepared for our perceptions of reality to be totally upended.
Well said. And speaking of upending our perceptions of reality, we've talked about space being potentially holographic, but what about time? If our universe is a projection, does that mean time, as we experience it, is also part of that illusion?
Now, that is a question that takes us even further down the rabbit hole.
Hmm.
We tend to think of time as linear, flowing from past to present to future.
Right.
But what if, in this holographic view of the universe, time is just another dimension being projected?
Okay.
What if the past, present, and future, they're all just as real or unreal as each other,
Yeah.
existing simultaneously within this grand cosmic hologram?
Okay, now you're really messing with my sense of reality. It's a lot to process, but incredibly fascinating to think about. And I think that's a perfect place to leave our listeners today, with a healthy dose of awe and a whole lot of questions to ponder. If this deep dive into the holographic principle has taught us anything, it's that the universe is far stranger and more wondrous than we could ever have imagined. So keep those minds open, keep exploring the edges of our understanding. And who knows what mind-blowing discoveries await us in the vast cosmic hologram we call home. Until next time, happy diving.